My name is Dr. Patel, Professor and Chief Soil Health Specialist, Patel University, Vadodara, and Mati Agromart Private Limited, Bhavnagar, Gujarat. So today the topic of my YouTube is why soil pH is so important. So why soil pH is so important? So there are 5 reasons soil pH affects how many nutrients reach your plant. Different plants prefer different pH levels. Soil pH range from 6.54 to 7.5 seems to be the ideal pH for most of agriculture crops. Nutrient deficiency can be a direct result of pH imbalances. pH value can affect the level of bacteria. Effect of abnormal soil pH on crop production. So you can see that when there is an optimum pH range, then shoot and root growth for plant is better as compared to the abnormal pH. So here again you can see that the root biomass in optimum pH range, whereas in abnormal pH, then the plant growth and root biomass is lesser. So we should have to maintain optimum soil pH. So what is the effect over root establishment, over plant vigor, over nodulation in legume? So you can see here over nodulation in legume, increase disease incidence, decrease in beneficial microorganism, and increase in plant pathogenic organism. So when there is an abnormal pH, then the microorganism growth is declined. Stunted growth of growth. You can see here the stunted growth when the soil pH is abnormal, plant showing with nutrient deficiency. So when there is abnormal soil pH greater than 7.5 or lesser than 6 pH, then there will be nutrient deficiency in plants. Because the nutrients are present in soil, but it is not available to the plant due to higher or lower soil pH, over flower and fruit setting. The desirable soil pH range for optimum plant growth varies among crops. Generally, soil pH 6.6 to 7.3 is acceptable for most plants as most nutrients become available in this pH range. Soil pH can be determined by mixing soil sample with water and then measuring the resulting aqueous solution. So here the neutral pH, the majority of the nutrients are available at that pH. When there is alkaline pH 7.4 to 9, so it is alkaline. So you can observe this in saline alkaline soil, and so in alkaline soil, sodium plays dominant. In acidic soil, less than 3.5 to 6.5. So here, when the acidic soil, then the dominance of the iron, aluminum, and manganese in the soil, and other nutrients are not available to the plant. So for the reclamation of the acidic soil, we should have to use lime to increase the soil pH. Whereas in alkaline soil, saline soil, we should have to use gypsum. So it is a different pH range. So here you can see that in Gujarat, the soil is saline and alkaline, so slightly alkaline. So in neutral 6.6 to 7.3 slightly alkaline, 7.4 to 7.8 moderately alkaline, 7.9 to 8.4 strongly alkaline, 8.5 to 9, and very strong alkaline greater than 9. So in alkaline sodic soil, sodium is dominant, and you know that the crop productivity is very low. So in Saurashtra area, the soil is saline, alkaline, and calcareous. So the farmers are growing the cotton crops, then groundnut crop, sesamum crop. So you can see here the saline sodic soil, the structure is deteriorated due to dominance of the sodium. Soil is dispersing. So soil containing both soluble salt and exchangeable sodium. So sodium is dangerous for the sodic or alkaline soil. In human being, sodium is also harmful. As we are knowing that when the sodium is content in blood is increasing, then there will be BP, blood pressure problem. So we can measure the soil pH using the digital pH meter. The effect on soil pH on nutrient availability. So I told that in neutral soil pH 6.5 to 7.5, the nitrogen, phosphorus, potassium, sulfur, calcium, magnesium, and molybdenum are more available, whereas the micronutrient iron, manganese, boron, copper, and zinc are more available at slightly acidic pH 6 to 6.5. But molybdenum is the exception micronutrient. It is more available in alkaline soil, means higher soil pH. Plant nutrient availability. Plant nutrient availability, the macronutrients such as nitrogen, calcium, potassium, magnesium, sulfur with phosphorus as an exception are more readily available in pH range of 6.5 to 8. So these nutrients except phosphorus are more available at 6.5 to 8 soil pH. The micronutrients, however, are available in slightly acidic pH of 5 to 7, I told. These are the optimal range in which nutrients are available to plant in favorable quantity. Availability becomes less outside these pH ranges. The molybdenum micronutrients availability decrease in alkaline conditions. When the alkalinity is increasing greater than 8, 9, then it will be decreasing. Also, nutrient element of iron, copper, manganese, zinc, and nickel are tightly bound at alkaline pH, and hence they are more readily available in lower pH levels. So micronutrients are less available at lower soil pH, and it is less available in alkaline soil pH. This can induce toxicity symptom in plant in acidic soil. So I told that in acidic soil, the toxicity of the iron, copper, manganese are observed. In crop production, we should have to maintain soil pH between 6 and 7. Some crops are more sensitive than others to soil pH. This tells us that a soil pH of 5.7 only is at 83%. When the 5.7, then corn oil is 83% of its potential. So for 6.8 soil pH, the corn, wheat, alfalfa, means lucerne, and soybean is 100%. But when the pH is 5.7, then crop will decline. Again, you can see when there is soil pH is 5, then again decline. But when the acidic soil, highly acidic soil, then you can see the corn yield is 34%, wheat 68%, lucerne, alfalfa 2%, and soybean 65%. So we should have to maintain the neutral soil pH for the higher crop yield potential. Buffering capacity. Buffering capacity retains the pH of the soil, means it resists the change in soil pH. Soil with high cation exchange capacity possess good buffering capacity. Like clay soil or black soil have a higher cation exchange capacity, which in turn can resist change in pH. Clay soil have a considerably high amount of cation exchange capacity than silt or sandy soil. So sandy soil or silty soil have low cation exchange capacity, so it has lower buffering capacity. In an alkaline or basic medium, the concentration of hydrogen ion is low. Hydrogen ion will compete less with other cation for exchange site, and more base cations will be remain on the particle exchange side. So suppose you have sandy soil or sandy loam soil, then you are continuously use the acidic fertilizers like urea, ammonium sulfate. Then there will be a possibility to decrease the soil pH. But in black soil, when you are used continuously nitrogenous fertilizer, urea, ammonium sulfate, but it cannot change the soil pH because black soil have a higher cation capacity, so it has a higher buffering capacity. So it resists the change in soil pH. Buffering capacity. Thus, the cations are least susceptible to leaching in alkaline condition. This process occurs reverse in acidic medium as hydrogen ion exchange the base cation from the exchange side. These nutrients are released in the soil solution, which is either taken up by the plant or incur leaching losses. The cation exchange capacity, the measuring in millicoulomb per 100 gram of soil, is depending upon clay and humus content. So sandy soil, the cationic capacity is less than 4. Silt loam soil, 8 to 22, and clay soil, black soil, 18 to 30. So changing soil pH, some fertilizer can change soil pH and increase or reduce the amount of nutrient available to plant. Fertilizers such as crushed sulfur and some ammonium sulfate nitrogen fertilizer lower pH and make soil more acid. So when we use the urea or ammonium sulfate, then the soil pH is declined. So you know that when we have the alkaline soil and pH is 8.2 or 5, then we are recommended to the farmer to use acidic fertilizer, ammonium fertilizer, then sulfur fertilizer, then urea, then sulfate of potash for reduction of the soil pH. But nitrate fertilizer has less effect on soil pH. We have observed by carried out soil analysis at Sevam Agri Clinic and Laboratory, Bhavnagar. From the area of Bhavnagar and Surendranagar, the soil samples show macro and micronutrient deficiency. All they have more organic carbon, organic matter greater than 0.75% in soil, and it might be due to high soil pH greater than 8. So soil pH is very important for the uptake of plant nutrient from the soil. So in the area of this Bhavnagar and Surendranagar, they have the soil have the higher organic matter, but we are observing the deficiency of the macro and micronutrients, particularly zinc, iron, copper, boron. So we are advised to the farmer that you should have to use the ammonium sulfate, urea, sulfate of potash, and sulfur fertilizers. But I have contacted with the farmers of that area. So the farmer told that they are using the mostly DAP. So I told that you should have to use superphosphate fertilizer and use more urea and ammonium sulfate for reduction of the soil pH so that the nutrients are more available to the plant. Then fertilizer and soil acidity. Soil acidification is a natural process in high rainfall environment where leaching slowly acidifies soil over time. So you will find the acidic soil in high rainfall area because acidified basis material has been washed out due to heavy rainfall area. So in Assam, we are of Himachal Pradesh, we have observed the acidic soil. Of all the major fertilizer nutrient, nitrogen is the main nutrient affecting soil pH, and soil can become more acidic or more alkaline depending on the type of nitrogen fertilizer used. I told that when we use the urea or ammonium sulfate, then the soil pH is declined. Nitrate-based products are the least acidifying of the nitrogen fertilizer, while ammonium-based products have the greatest potential to acidify soil. So I have discussed this thing. Then soil acidification due to use of phosphorus fertilizer is small compared to that attributed to nitrogen. Phosphoric acid is the most acidifying phosphorus fertilizers. Soil acidification due to use of sulfur fertilizer is also small compared to that attributed to nitrogen due to the lower amount of this nutrient used and the lower acidification per kg of sulfur. Elemental sulfur is the most acidifying sulfur fertilizer. So when the soil pH is greater, 8, more than 8, then we are recommending elemental sulfur to lower down the soil pH of the saline or alkaline soil. Potassium fertilizer have little or no effect on soil pH, but if we are using the sulfate of potash, then sulfur play important role to reduce the soil pH. Effect of pH on fertilizer efficiency. So you can see that at soil pH 7, average fertilizer wastage is 0. Thank you for very much.